In this video we're going to take a look at the blackSquare challenge on HackTheBox. So this is an easy Stego challenge, and the description says, is Malevich's blackSquare so simple? Or Malevich's. I haven't completed this challenge yet, so this is completely new to me. We'll download the files first of all and check them out. So we've got a PNG image. Let's copy this over. And let's have a look at the image first of all. Alright, so as the description and the title alludes, it's a black square. It is a different shade of black to the, you can see to the actual, I don't know if you can see on the video, but it is a different shade of black to like the application here. Alright, so let's go and do some basic file checks. So we'll confirm the file type first. It is PNG image. Let's have a look at the EXIF data. Not too much compared to what we might see with a JPEG. Let's have a look at the strings. We'll do strings-n8 blackSquare, and I don't see any strings sticking out to us. So let's try and run foremost. Nothing in the output, but we had an issue before where foremost wasn't. Well, I think it just wasn't doing recursive extracting, but let's run bin walk anyway. Alright, nope, nothing. Gonna remove that folder, and let's have a look at some Stego tools. So we'll open Stego Suite first of all. Or not Stego Suite, StegSolve. And this is just to do some kind of visual checks. So we'll go through color inversion, check the different planes to see if any of them have any. So you see there, even though the image is completely black, if we check the red plane 2, red plane 1, red plane 0, we can see that there's some data. And green plane 2, 1, 0, presumably the blue plane as well. Look at this, 2, 1, 0. Okay, can we zoom in on that? Let's quickly have a look at the stereogram solver. Nothing there. So we probably want to have a look at data extract, and this looks interesting just because it's only in the corner of the image, which is the blue planes, right? So blue plane 0, 1, 2. So if we were to say blue plane 0, 1, 2, preview, does it show any kind of text there? Doesn't look like it. We have something here, some values here. Let's try and save it as text anyway. Just call this blue plane, and let's have a look. Cat blue plane. Okay, so it's not really giving us. What about if we do strings blue plane? No. Alright, so the way that it's formatted, that kind of looks like the hex format. Let's try saving bin. I'm just gonna overwrite that if I can, and let's check that out now. So file. Oh, it's because we have that black square there. I can't autocomplete. I'm trying to do autocomplete with BL each time. Okay, so it just says data. Let's cat out blue plane. Oh god, I'm gonna name it something different next time. Okay, so we've catted that out there. There's no recognizable strings in it, but it's saved as a better format anyway. Let's try and do this with the various planes. So we also had the green plane 0, 1, 2, and then the same with the red plane. So can we go 0, 1, 2, 0, 1, 2, and try and preview it first of all. Alright, that's looking, well, I'm not seeing any strings there, but it's there's plenty of data anyway. Let's try and save it. I'm gonna call this all planes, and let's take a look at that. And it's PGP symmetric key encrypted data, AES with 256-bit key. Okay, that's the file type. Just out of interest, I want to see as well if we were to extract that without the blue plane, which just had the data in the corner. What does it come out? Does it still show as a as the same file type? Let's call this just call this extra. Probably remove it if it's nothing of interest. File type extra. Alright, so it's just data. So yeah, it looks like we needed all the planes there. Okay. Let's remove the extra, and I'm going to remove the blue plane. Okay, so we've just got the. We didn't have any useful strings in blackSquare now. Okay, let's go and investigate this PGP key then. Was it PGP key? PGP symmetric key encrypted data, and see what we can do with this. So PGP decrypt. We've got some online tools. Let's see. Oh, we can do this with CyberChef. Awesome. Okay, so input. Let's try. Oh no, not a tab. Let's try to open a file as input. And HackTheBox Stego. We'll give it the all planes file. Enter the private key of the recipient. Now we need the private key. So we have the data. We need to also find the private key. Let's go back. Random color maps. Okay, maybe private key of the recipient. So maybe if we try to, I mean, I can't really think of anything else to extract apart from do the individual planes. We didn't try to extract the red plane individually. Let's data extract. Okay, we already had that open. Let's go back to the one we had open. Let's just do the red plane. Say bin red, and then I'm also gonna save the green as well. We only did the blue earlier, so green. Just want to check these file types. File green data. File red data. Okay, no. So I'm not sure whether maybe this is just the fact that this showed up as that file type was an error, like how whenever we do like zsteg -a to do the all checks on blackSquare, you see that it'll find different data types in there, and in some of the previous challenges we've looked at, we've seen that, and we did actually try to extract, I think, an MPEG file from one of the challenges. So I guess that's what's happening whenever we're extracting the plane. There you can see these different data types, but they're not necessarily actually files of that type embedded in there. It's just what, you know, could potentially be extracted. Unless we get something else that can be used as a private key and the passphrase, then we'll have to move on from this avenue of exploitation and see what else is available to us. So something I'm particularly interested to do here is to extract this data here, because there's no option, there's no way for me to zoom in on this. So I want to try and extract this data here and see if we can get a bigger look at it. I mean, it could even be some text or something if we add these three planes together, you know. So that's the goal. Let's try and Google here. Extract plane to new image, possibly ImageMagick, although bitplane merging. I find that sometimes with ImageMagick, if you don't know the documentation, there's not always people looking for, or like kind of just posting problems and solutions on Stack Overflow necessarily for the problems you want, and you can sometimes needs to go through the documentation, which maybe there'll be a quicker way for us to do this for now. Let me search CTF Stego extract plane to new image, and we might in one of the previous walkthroughs or write-ups get something that'll help us. This is interesting. StegOnline, a new GUI steganography tool. Been developing an online Stego tool, open source. Okay, and you can drag and drop an image by the looks of it, and then extract files, embed files and data. We can XOR the image. We can view the planes individually. So maybe we'll be able to view the plane individually and then save the new image. Extract all RGBA values. All right, let's have a look at this site. This sounds pretty cool. Where's the link to it? We can view it here, or we can view the project on GitHub. Let's have a look at this. We'll upload the image, and it's in CTF, HackTheBox Stego, blackSquare. So we've got the image here. So presumably we can do show. Oh, full green. I was kind of expecting that to. No. Okay. LSB half. Okay, the LSB half gives us a bit of a new kind of look. How do I deactivate that? Or reset? Okay, reset. What about browse the bit planes? Because it's the green bit plane, not the green bit planes. It's the blue bit planes that we're interested in. Blue 0, 1, and 2. Preload. Okay. So we can. Let me just go to extract files and data. Extract data. This is just going to do what we did there, really. It's not going to give us an image by the looks of it. Let's just hit go anyway. No, so it gave us the ASCII text there. It's not giving us that as an image. Let's go back, and I mean, potentially a quicker way, kind of quick way we could do this would be to save each one of these images. If we save, it's not going to give me the option to give it a name. Okay, there's the. Alright, let's move the downloads blackSquare to blue1.png, and then we'll do this with the blue2. And then we'll do this with blue 3. Oh, we should have done it with blue 0. Let's do it with blue 0. Okay. So that's fine. Let's see if we can use ImageMagick now to combine these. Let's actually double check our images as well. Blue 0, blue 2 and blue 1. That's not looking too good, because whenever we look here, blue 0 blue 1 and blue 2 don't look anything like what we downloaded there, so I'm not too sure what that's about. What about this show RGBA values? Does this apply for all? Let's see, browse bitplanes. Okay, if we go to reset, browse bitplanes, let's go to blue. Just try and open this. Yeah, that's not really what I was expecting to see there, considering the top left corner doesn't look any different to. Let's open one of them in the hex editor. Blue 0. Let's go back then to our StegSolve program and try to save. We can view the planes in here, so let's try to just save plane 0 and we'll save it right here. Let's have a look at that. Yeah, okay, blue 0, that's looking good. Let's do the same for plane 1. Save it as blue 1. And then we'll do the same for plane 2. And then we should have those 3. Let's delete some of these. So we have our black square, and then we have blue 0, which we can now zoom in on to a certain degree. That's as far as we can go? Yeah, that's as far as we can go. Oh no, okay. We can zoom in, okay, and then we can go to our next one. Same, we need to zoom in on that. And we need to zoom in on that. So this is looking like Morse code. You can see here some Morse code examples. It's looking quite similar to what we have here, but presumably we need to merge these 3 different images together in order to, before we can then decode it with the Morse code. So let's try and combine those, see if there's a way to do that with ImageMagick. Now, I'm no expert with ImageMagick. I'm thinking that probably what we're going to want to do is inverse these so it's black on a white background, and then convert the white to transparent, and then just overlay the 3 images, presumably. If anybody knows a better way, I'd be interested to know. Let's try and I'm going to do convert. Let's do the blue 0 and channel RGB dash negate, and then I'm going to do inverted blue 0.png, and let's see what happened. Yeah, that's worked for us. So I'm going to do that with the same with the 1 and 2. Now we have 3 inverted images. Let's see if we can make the white background transparent and then overlay the 3 images together. Try and get the backgrounds converted to transparent as well. Let's try and do convert, and we'll give it the blue 0. Oh wait, let's get rid of these. So we only have the blue eye. Oh, so it's eye blue 0. We're going to convert that, and we'll say transparent. We could have actually, so we're going to say transparent white here, but we could have actually done that with black actually, and then I guess converted the Morse code. I think this is going to be the best way to do it. Let's try this and do. I'm going to convert this just to blue 0 now then. Unrecognized option. Okay, I spelled transparent wrong. There we go. Let's check that out. We now have this blue PNG. Yeah, transparent background, but if you zoom in, you'll see that we have the black there. Okay, let's do that for the blue one as well, and blue 2. We now have our 3 new images. We'll get rid of these old I ones. Now all we need to do is overlay these together, and then we might want to put a white background on it as well. So let's try and combine these. Let's do convert, and I'm going to do blue. I'm going to do all of the blue files, and then let's say background. We might just be able to say background white here. Layers, flatten, and then we'll call it final.png. That's converted. Let's see, and we'll see that that's actually combined those all into one, and it's given us a background as well. Note that whenever we zoom in, I had to modify the preferences here. In the preferences, the image view, it was set to smooth images when zoomed in, which means you can see it's like blurred there, so it's no longer blurred. So we have this together. Now we can go and try to decode the Morse code. So let's first of all see if we can go and do some of that manually, just to make sure that we're going down the right tracks. So if we go online, look for a Morse code translator. I already have one in my favorites here from previous CTF challenges. And we can see here that we can convert text to Morse code. So I can say hello, and it's going to come out with a Morse code here. And we can similarly input our own Morse code using dots and dashes or underscores, and letters are separated by spaces and words by the slash or the pipes sign. So we could let's make it so we can see both of these at once, and give ourselves some room. And we could go through and say, okay, well, it looks like we have a dot space dash space dot space dot space dash space dash space dot space, or maybe that's coming out all ETs there, and I see that some of the spaces appear to be bigger than others there. Let's try and do dot space dash space dot dash dash dot space dash dot. We expect this to come out as some kind of recognizable text. It's not doing that for us. Alright, so I just spent quite a bit of time off camera there playing around with this, and I ended up having to refer to this online write-up by Felipe because I wasn't able to translate this Morse code into anything useful. And let's scroll up here. According to this walkthrough, they use a slightly different technique. So they use the LSB half feature here on the you can see this LSB half option, and then they use this image, which they've then done some processing on and basically extracted the black parts of the image and then done some more modifications to get this Morse code. So the Morse code is quite different to what I have there, and if you were to go through with this Morse code, we have dash dash space dash dash dash. Let's have a look. Dash dash space dash dash dash, and then space dot dash dot. So space dot dash dot. You can see it looks like it's going to start to say Morse code here. So we need to end up with this same Morse code. So if we were to go here and try to save the current image, you notice we open that and it doesn't even, for some reason, that's not what we see here. So that's not going to work for us. Let's try and save this image, and we'll save it into our working directory. I'm going to call it, I'll call it half.png. And in their example then, they're going through and they crop it first, get rid of all the pixels that aren't black, and then they go through with their Morse code. So I could crop it based on the size of this, rather than using, hopefully we won't need to use this bucket fill tool. We'll go through and we'll see if we can only extract the, we'll remove everything but the black from the image using ImageMagick. Let's try and do that now. So we're going to use the convert command here again, and we'll pass in our half.png. This time we'll set a threshold, and this threshold can be a different values. I'm going to set it just here as an example at 20. We'll pass in, we want a new file name, so we'll call it new.png. And then if we go to have a look at new.png, okay, let's actually compare new.png to final.png, which was the one that where we extracted. This was the one which wasn't working for us, basically. So let's try and zoom in. This is the final. Okay, and then this is the new. Let's see if it's looking better. It is looking better, so we have dash dash space dash 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 space dot dash dot. Let's check out the next line on the Morse code analyzer and see if this has worked for us. So move this over here so we can see it. So dot 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 space dash dot dash dot Morse or Morse code it's going to say, I guess. Let's do the next line. Dash 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 space dash dot dot space dot. Yeah, Morse code. So we could go through manually typing this out, and it's cool that that worked for us. Let's see, out of interest, if we would have done this as, let's do 90, and I'm going to say threshold at 90. I just want to see whether that's any different for us. Okay, still worked in this case. So essentially what we've done there is we've split it so it's only black and white, and because if we looked at the half image, you know, a lot of it was color. We've basically just taken it so we only have the black and white there. So we could go through this manually and get our flag. Why don't we check out this script which was in the walkthrough from Felipe, which I'll put this walkthrough link in the description as well. They put a script together to try and convert that into regular text. So rather than typing through this all manually, let's run through the script and see if it works for us. So let's view raw, and we'll do wget convert Morse. What does it take in? It takes in image open blackSquare filtered PNG. Okay, let's open this up. Let's open up actually Codium convert Morse, and we have ours saved in new.png at the moment. So let's just set this to new.png. Let's run Python convert Morse. We get invalid syntax. Can we do Python 2 convert Morse? Invalid syntax again. Let's go and have a look at this. Line 8. So we have a V here which was missing a quote. Let's try that again. Python, convert Morse, and here we get a decoded message. Morse code is the same method used in telecommunications to encode text, characters, standard sequences, two different sig something, etc. Where's our flag? Flag is learn Morse code. Learn Morse code. Let's see if this is our flag. We'll go and submit that. Hack the box. I'm going to say this was quite difficult. And then we get a flag accepted. Alright, I hope you've enjoyed this video. I think this was, because I hadn't solved this already, there was a bit, probably took a lot longer than some of the other videos that we've been through where it was my second time solving them. But that's it solved. I hope you've enjoyed this video. Check out the walkthrough with this script. A great script for solving that, which I'll link in the description. And any questions, comments, leave them down below. Thanks.